So today we are going to solve LeetCode 859, that is buddy strings. So in this question we are provided with two strings, that is S and goal, and we have to return true if we can swap two letters in S such that the resultant will be equal to goal. Otherwise we have to return false. So this was the question. Now let's try to understand with what approach we can solve this question. So here are few cases that will help us to understand how we can approach this particular question. So let's see the first example, that is this one. So we can see that the length of S is equivalent to the length of goal, right? But what if the S is equivalent to ABA and goal is equivalent to AB? In this case, we can clearly see that S is not the length of S is not equivalent to the length of goal. So even if I am going to swap any of these elements, so there won't be even a single possibility that this string is going to be equal to goal, right? So right away we can say that whenever the length of strings are different, we won't be proceeding for swapping. We can right away return false. So this is the one case that we understood. Now let's try to understand this example, that is S is equals to AB and goal is equals to BA. So this is quite straightforward, that when we are going to swap A and B, it is going to be equivalent to BA, right? So I am saying I am swapping S of I and S of J, and what I am getting, I am saying whenever I am going to swap these elements, I have to check S of I, that is A, is equivalent to J of goal, right? That is A. So these two have to be similar, then only after swapping I am going to get the equal result, equal strings. And not only this one, I am swapping I with J. So I have to check this as well. The S of J is also equals to goal of I. That is S of J is B is equal to goal of I. That is also B. So I have to check this condition. So we are clear with that, right? Whenever we are going to swap, we have to make sure that S of I have to be equivalent to goal of J. And goal of I should be equivalent to S of J. So this is clear to us. This was the straightforward example. So we can say that this case 1 will return true. Now let's try to understand case 2. In case 2, we can see S is equivalent to goal, right? S is equivalent to goal. Both are AB and AP. So even if I am going to swap A and B, right, it will become BA, right? They will become BA. And we know that in this case, BA won't be equal to AB. So this is one case when the length is also same and the strings are also same, but still each and every character is appearing for once. The count of each and every character in both these strings is equivalent to 1. Therefore, we won't be able to swap element, or after swapping we won't get the required result, expected results. So we understand when S is equivalent to goal and each and every character count is equivalent to 1, in that case we will return false, right? But what if S is equivalent to goal but character count is not equivalent to 1? Like we can see in third case that S is equivalent to goal, right? Both are AA. But in this case we can see that S of I is equivalent to goal of J, right? and S of j is also equivalent to goal of I. So in this case, we can swap. We can swap, and we know after swapping, we will again having the same result, expected result. So in this case, when the S is equivalent to goal and the character count in that string is not equivalent to 1, there are repeated characters. In that case, when there are repeated letters, repeated characters, then we can say we can swap and we can return it. So we can say that case 2 will return false. So we can say that case 2 will return false and case 3 will return true. Now let's try to understand case 4. In case 4, we can see that both the strings are of same length, right? Length of S is equivalent to length of goal, right? But we can see that these strings are not same. S is not equivalent to goal. In this case, what we have to check? We have to check two indices. We have to check two indices in such a way that when we are going to swap these indices, it will become equal to goal. But again, that first thing that we already saw, that one condition that we already discussed is required, and that is if I'm saying S of 3, that is 0, 1, 2, 3, S of 3 is equivalent to D, and I'm saying S of 3 should be equivalent to goal J. Goal J will be 4, right? But these two are not equal. If these two are not equal, so we won't be able to swap it and we will return false. But in next case, we can see that ED and DE are there, right? So in that case, S3 is equivalent to goal 4, right? E is equivalent to E, and same will go for Sj and goal I, that will be D. So in that case, we can say case 5 will return true because this condition is satisfied. So by these cases, we understand this will return false and this will return true. Now, after analyzing these 5 cases, what we understood, like we firstly got to know that there will be one. Firstly, we have to add conditions for cases like the one that we just discussed, that is if length of these strings are different, are not same, right? This will be one edge case. So for this we will be returning false. Then second case will be if length is same and strings are also same, like these two. Length is same and strings are also same. In that case, what we have to check? We have to check the count of letters. Repetition is required. Repetition is a need. And if that's not the case, like if strings length are same but strings are different, in that S of I should be equivalent to goal of J and vice versa. That is S of J should also be equivalent to goal of I. Then only we are going to swap. But there is one more case which will come in this third condition only, in this third condition where we are saying that length is same but strings are not same. In this third case only, we are going to add one more condition, and that is if S is equivalent to A, B, C, E, D, and I'm saying goal is equivalent to A, B, G, D, E. Now in this case, we can see we are having 3 indexes to swap, right? These 3 indexes in S. But this will never lead us to the expected result, as I am going to swap E and D and this will become DE, but still there is C and this is G, right? this is C and this is G. So what I'm trying to say is, if there are more than 2 indexes in S with different characters than G, then also we won't be able to proceed. In that case as well, we are going to return false. So this will be one case which we have to check in this third case itself. This will be this is going to be checked when we are going to find I and J in these strings. When we are going to find I and J, we are going to check this condition as well. If there are more than 2 indices at which there are different characters in S in comparison to goal, then what we are going to do, we are going to return false. We are going to return true only when this condition is going to be satisfied. So after analyzing these cases, now let's go and try to code this whole solution. So firstly, this is the algorithm. This is similar to the explanation that we just had drawn. So we can see that firstly we will check if the length of the S is not equivalent to the length of goal, then we will return false. Then what was the next case? If S and G are equal. In that case, what we were saying? We were saying if there are repetition of letters, then only we will be able to swap and we will return true. If there is no repetition, then we won't be able to swap and we will return false. Then lastly, what we were doing, we were going through the whole string and we were trying to find I and J such that S of I should be equivalent to goal J and goal of I should be equivalent to Sj. So this is the third one. But if there are more than 2 indices in S with different letters than goal in comparison to goal, then what we will do, we will again return false. Okay, let's first try to code this and then we will jump to time complexity part. So as we wrote in the algorithm, if length of S is not equivalent to length of goal, then what I'm saying just return false. Next case is if S is equivalent to goal, then check for frequency. There will be a frequency array. Hash map can also be used rather than this array. It's up to you. So what I'm saying now, check frequency of each and every character in S. So this will be something like frequency. I've created a frequency array, initialize it with 0 and the size is going to be 26. As we know, in a string there can be only characters from A to Z. There can be only 26 alphabetical characters. There are only 26 alphabets. So whenever we will encounter an alphabet in a string, we are going to increase the frequency by 1. And as soon as we increase the frequency, what I am saying, check the value is equivalent to 2. I'm saying try after increasing frequency every time, I'm saying just check if its frequency is 2. If we are having even a single alphabet with frequency equivalent to 2, so we know that we will be able to swap. That's what I'm saying. But what if we have traversed this whole string and we never achieve this condition? In that case, return false. This is one case. Now when these two cases are not working, what we were doing, we are trying to find 2 indexes. That is first index, let's just mark it as -1, and there will be second index. Let's mark it as well, mark -1. Now what I'm saying, try to iterate over this again for I in range length of S and check if S of I is not equivalent to goal of I, then what we have to do, we found the first index, we will update first index if it's not updated yet. So first index will be I. But if it's already updated, right? But if it's already updated, so we will check for second index. We will update it with this I. But if both the indexes are updated, in that case, what we just saw in the example, that if there are more than two indexes, then we won't be able to make this string equal to goal ever. So in that case, we will simply return false. And after iterating this whole string, what we are going to check? We are going to check are both the variables are updated or not. So if first index is updated and second index is not updated, then also we won't be able to swap, right? Because we want at least two index to swap. That's why we are checking if second index is still equivalent to -1. Still equivalent to -1, then just return false. Return false. And lastly, we are saying S of first index is equivalent to goal of second index, and S of second index would also be equivalent to goal of first index. So if this condition is satisfied, then only return true, else return false. Let's try to run this. Maybe there must be a typo. Line 22, it's return. I guess rest is fine. Okay, so we can see that this question is working and it's quite efficient as well. So now let's try to understand what's the time complexity of this solution is. So as we can see in our code, we are iterating this string s once, right? Here as well once in this case. If this is not the case, then too we are iterating only once. So in that case, time complexity will be big O of n, right? Time complexity will be big O of n. And for a space complexity, we can see that we are having this frequency array in this condition, but this array is always going to be constant as there will always be 26 alphabets only, right? So we require a constant frequency array. So for that, space complexity will be big O of 1. So time complexity is big O of n and space complexity is big O of 1. So this was the whole solution. It was a easy level solution but requires a bit of analytical thinking with some cases because there are multiple edge cases as we saw. Overall, the question was really nice. The question is easy but requires a bit of analysis in terms of edge cases like we already saw in our dry run. So this was the whole solution and I hope this video was helpful. And if you find this video helpful, then you can like this video, subscribe my channel because I will be coming up soon with few more questions. So for that, stay tuned and thanks for watching.